All right, welcome everyone. Today's learning series presentation, Opportunities in Retro Commissioning, also known as RCX. This is part of our learning series where we do dives into topics to help expand your knowledge on certain topics. And we're happy today to talk about retro commissioning. So now I'm going to go through some housekeeping. So the default is computer audio, but if you have any issues with your audio today, sometimes switching to no audio and then back to computer audio will fix that. And if not, use the phone call option. In the control panel, you'll see the phone number to call in, and that's another way to connect. Please type in questions as we go along. There's a Q&A panel in your control panel, and as we go along, as you get a question, type it in there. We do have time for Q&A at the end, and we love your participation in answering questions. All right, so our presenter today is Corey Toole. He's a senior engineering manager here at CLEAResult, and he's been working in the energy efficiency space since 2004, including more than a decade leading RCX project implementation. He has been with CLEAResult for the past 7 years and manages engineering support for utility programs throughout Oklahoma, Texas, New Mexico, Colorado, in addition to leading the RCX subject matter expert group here for us. And so with that, Corey, I'm going to hand it over to you to talk about today's agenda.
All right. Thank you very much, Nick. It's great to be with all of you today. Good afternoon to everyone. And I'm happy to be here talking about one of my favorite subjects in the industry, which is retro commissioning. So just a quick overview of our agenda for today. I'll start out giving a little introduction to us at CLEAResult, our engineering team, and focus on retro commissioning. Then we'll talk about what retro commissioning really is and why it's important. I'll highlight some typical measures and savings that can be expected from these projects, and then talk about some ways to increase persistence of those savings over time. I have a couple of case studies that I want to share with you today, and then we'll get into some ideas and considerations in designing a retro commissioning program within a demand-side management program. Finally, we'll wrap up talking a little bit about what is happening beyond retro commissioning and some of the future trends that we're seeing there. So first of all, to tell you a little bit about us here at CLEAResult. Our engineering team is about 140 engineers strong. We have a lot of combined experience in energy efficiency across many different avenues and opportunities. We have subject matter experts across our team. We have the ability to collaborate with each other, to share resources, to learn from one another. We're also very connected to industry trends because of the many programs that we support. We're connected to local, regional, and industry-wide trends and have a library of managed and maintained tools and calculators that help us to do our jobs better. Within our engineering team, we have over 20 subject matter expert groups, and I've listed a few of them here on this slide. We also have many engineers who are credentialed either as professional engineers or in other industry recognized licenses and certifications. And we're supporting over 350 different energy efficiency programs across North America. My favorite subject matter expert group happens to be the one that I lead, which is our retro commissioning SME group. We have 25 engineers participating in this group with a variety of different backgrounds and experience related to retro commissioning. Many of us work with programs, or retro commissioning is a measure across programs that we implement. Some of our group comes from controls or mechanical contractor backgrounds. Others have design experience, and some, like myself, have worked as retro commissioning or commissioning engineers, implementing these projects for customers. Over on the right here, I've listed some of the programs that we are involved in currently across the United States and Canada related to retro commissioning. And just want to highlight that this spans both electric utilities as well as gas utilities. We also have a team, our design build team, that implements direct to customer work for retro commissioning projects. So I want to talk a little bit about what retro commissioning is, to kind of define that here from the onset so that we're all on the same page with what this means. So in short, retro commissioning is a process that seeks to improve how building equipment and systems function together. There's some goals with this, some purposes that we try to achieve in these projects, among which are trying to resolve problems that may have been there since the building was designed or constructed. Other problems that may have surfaced over the building's lifetime, we try to address those. We want to improve a building's operations and maintenance procedures, enhance its overall performance, and improve its efficiency. That means producing energy savings, both on the heating and cooling side, which can include both gas and electric savings. Now, what type of buildings are we looking for? Primarily, we're looking in retro commissioning for large commercial buildings, hospitals or universities, office buildings, data centers, or large central plants for distributed chilled water or steam systems. We want buildings that have a building automation system that is direct digital control. As we focus in on these types of buildings, we want to look for those that have some complexity in their HVAC systems. If they have never been commissioned before, or if it's been a while since they have undergone commissioning, they may be good candidates for this process. If the buildings have had significant changes to their space or function, if there's been major retrofits that have happened, or they're being used differently than originally designed, that can be a great opportunity for this process. Or if you've noticed high energy consumption, higher than expected, or persistent comfort complaints. One of the great things about retro commissioning in this process, as we seek to optimize energy, we're also hoping to optimize comfort and improve comfort levels throughout the building. Finally, if there have been major capital upgrades, sometimes that can be a great opportunity to bring in retro commissioning and just make sure that all of that equipment and those systems are operating together in the way that they should. So who can provide this? Who can provide retro commissioning to a customer? What we prefer, what we look for in a retro commissioning provider is an engineering firm that has experience in the field, has a good knowledge of HVAC systems and controls, and preferably one that has expertise within measurement and verification to help understand the savings that are achieved from this process. There are a number of certifications throughout the industry, and you'll recognize some of these industry associations here that certify commissioning or retro commissioning providers. Having this certification doesn't guarantee that a firm or a person will be well qualified for a particular project, but it is at least an indication that they've had some exposure to the process and some training. Now, one of the things we have seen across the programs that we work with is that sometimes there are challenges in finding these types of firms within a local market. And so one of the ways that we've seen that addressed is that sometimes that requires firms to engage from across different states or territories. Retro commissioning is a team process. It requires input and collaboration from a team. So just want to talk a little bit about who that team would be for these types of projects. Number one would be our building owner. So the owner has to have skin in the game, be committed to this process for it to be successful. Now, when we say owner, we're talking about potentially a number of different people that could be involved. An executive sponsor, for example, someone from the owner side who will be the project lead. This will include maintenance staff or control staff that are involved in this building, that are running this building day in and day out. as well as any long-term contractors who would have a lot of experience and exposure particularly in the BAS and mechanical side of the building. The team will involve the commissioning provider, of course, that qualified firm as we just talked about, as well as any subcontractors or implementation contractors that will assist in implementing the measures that are identified. Finally, we want to make sure that the utility program representative is involved from the start on these projects as we work through potentially incentivizing the project. So what does the process look like? Well, it starts with a planning phase. During that phase, there is a high-level retro-commissioning assessment that's done to just kind of identify what is the opportunity here. Is this a good candidate for this project? What can we expect to find? Along that process, we're establishing an energy baseline to understand how the building has been operating. And we form that retro-commissioning team. From there, we move into the investigation phase. This is a phase where we're really going to be doing a deep dive into the equipment and the systems, monitoring them, functionally testing them, finding out is what the control system saying, is that actually happening in the field? Where do we have issues there? And through all of that process, developing a retro-commissioning plan where we really detail what those measures and opportunities are and how to implement them. Once that's been established, we move into the implementation phase, where these opportunities and measures are implemented within the facility. As they're implemented, they're tested, they're fine-tuned, there's follow-up that happens. And this implementation phase can take quite a while because often a measure that's implemented in the summer needs to be tested again in the wintertime, for example. So there's some seasonal components to this that we need to make sure that it's working properly and optimally. When all of that is complete, those measures are implemented, tested, and fine-tuned, then there is a handoff where that final report is delivered to the owner. That final report will detail what all has been implemented, what savings are expected, and will just document the improvements that have happened. Along with that final report, an important and critical component of this process is training. Training that happens to the facility staff, to the owner side, and any relevant contractors associated with how that building should be operated optimally. That will help in our persistence, and I'll talk more about that later. Finally, depending on the project and the scope, there will often be some follow-up and measurement verification that will happen as part of this process. So why is retro-commissioning important? To start out this part of the discussion, I want to harken back to a presentation given by one of my colleagues on part of this series, Kyle Hemme, who gave a presentation a few months ago about lighting opportunities within the energy efficiency portfolios. I just have one slide from his presentation here, but it's an impactful one because it talks about different market saturation scenarios that we can expect over the next few years as related to lighting retrofits. The key takeaway here, what I took from this, is that we need to identify other opportunities outside of lighting retrofits to help achieve savings targets and goals as we move towards the future. So as we think about those additional opportunities and what else is out there, buildings are an opportunity for us to really take a close look at. According to the International Energy Agency, buildings account for 30% of global final energy consumption and 26% of global energy-related emissions. So a huge component in the way that our world uses energy is through buildings. There's a huge survey of buildings that's done in the United States called Commercial Buildings Energy Consumption Survey. And that's done and redone periodically every several years. So the most recent one of those was in 2018. And I've got some data here on the right that kind of shows a breakdown on average of where energy is used within buildings, commercial buildings in the US. What is interesting and important for this conversation is that they show on average 52% of energy in US commercial buildings are used in the HVAC, heating, ventilation, and air conditioning components of the building. This study also provided this graphic, and I just wanted to show this as we talk about different building types and what might be applicable to this opportunity. Again, we're targeting the larger types, the hospitals, the large schools or universities, big office buildings. However, there are some opportunities out there within retro-commissioning, I'll talk a little bit more about, for some on the smaller end of things. As we look at commercial building stock in the United States, and these graphs also come from that CBEX, or Commercial Buildings Energy Consumption Survey from 2018, we can see this trend over time of commercial, both the number of commercial buildings as well as the total commercial floor space and its increase. So in this most recent survey, we were up to almost 6 million buildings in the US and close to 100 billion square feet of commercial space. On the right, there's a breakdown of kind of where those, the number of buildings within each of those facility types. Not all of those would be well suited to retro commissioning, but many of them would be. I know that many of you are, or some of you are listening from Canada today, and so didn't want you to feel left out. The National Resources Canada's Office of Energy Efficiency provided this data in 2014 on the different building types, number of buildings, floor space in square meters, and energy intensity. So my question for all of you to think about is, what do these opportunities look like in your territory and your customer base? Do you have insight into how this is broken out among your customers? Our market analytics team at CLEAResult has helped many of our clients understand the specifics of their market and their opportunities. So why is this important? Well, it's important in thinking about energy consumption globally and energy consumption within buildings to have great standards for new construction, right? That's important. Those codes and standards are continually evolving. But the reality is, according to the UK Green Building Council, 80% of the buildings that will be around in the year 2050 are already here. They've already been built. And so we've got this huge opportunity and this huge need to address energy consumption within the buildings that are already here with us today, because they're going to be around for a long time. Many of those buildings that are out there have never been commissioned, and many of them have changed significantly in the way that they use the spaces, the layout, and their function over time. There was a landmark study done on commissioning back in around 2009, 2010 by Evan Mills, and he collected all this information on buildings that had been commissioned or retro-commissioned over time. He pulled a lot of great information from that study. One of those is this chart that I'm showing here. There were over 100 deficiencies identified across these different commissioning projects. He's pulled together the top 13 of those deficiencies and tried to put a number on sort of the energy waste that was happening in those and what that would cost in terms of $1 billion per year across the US. It's hard to put an exact number on that, but this study estimated that somewhere between $3 and $17 billion a year was going to expenditures on energy that was completely wasted. Not energy that was helping a customer or an occupant feel more comfortable or helping a building perform better. Simply energy that was wasted through leakage, through airflow not being balanced, through dampers not working properly, all these things that you see here on this chart. So it's a tremendous opportunity to optimize these, many of which are low-cost operational maintenance type issues that can be addressed. So with that in mind, I'd like to talk a little bit about typical energy conservation measures that are identified through these retro-commissioning projects. Now, we could have an entire training series on these types of measures if we really wanted to get into depth on what they mean, how they're identified, how to optimize them. And I don't have time for that today, but I did want to just give you a taste of what some of these are. When we talk about air side versus water side, just so everyone understands that, air side would have to do with fans and air movement throughout a building as air is utilized to condition, to heat or cool a space. The water side would have to do with chilled water or heating water or steam that is circulated throughout a building to help condition that building. There are a number of opportunities, and these are just a few examples of measures that we see a lot of on both air side and water side. I don't have time to dig in deeply to these, but I did want to give you a flavor of just a few of these real quick to let you understand kind of what a retro commissioning engineer, what this process would be looking to identify. So on the air side, as well as the water side, scheduling would be a big opportunity to focus on in retro commissioning. Trying to turn things off or set things back when they aren't needed, when the building is unoccupied, there's no one there, when it's not a critical space, can we turn that off? Can we set it back and thereby save energy during those periods of time? You can't save any more energy than turning something off. So we want to identify what can be turned off and how to optimize that. What are the ways to bring it on at the right time so that people are comfortable when they come into work or whatever that space is used for. On the water side, one of the common measures is optimizing the staging of chillers. Chillers provide chilled water, which provides cooling to spaces, to air handling units and other equipment. And so in a large facility with multiple chillers, we want to make sure that our most efficient chiller at that particular moment, that particular load, is being utilized so that we minimize our energy consumption while still providing the cooling that is needed in that building. Finally, want to just mention another component on the water side, which is pumps, whether that be a boiler hot water system or a chilled water system. How do we utilize pumps most effectively? And one of those measures that we look at is variable frequency drives and how to optimize their control with differential pressure. Making sure that a building is not just set up for full load, maximum capacity, but is it still optimal when it's lightly loaded, when there aren't very many people there in the space, or it's a shoulder season. HVAC measures are not the only measures that are looked at in a retro commissioning process, although they are the primary ones that we focus on. But there's other measures that can be considered as well, particularly in a building that may have lighting controls or that functionality. We want to look at how to optimize those. The building envelope could be considered to make sure that pressurization is adequate, that infiltration is minimized. If the building has significant process equipment, that is something that could be looked at as well in this process. The focus of retro commissioning is on these low-cost operational and control and maintenance type measures. However, anytime you're digging deep into a building and really testing all this equipment and understanding how it works together, you're naturally going to identify capital opportunities as well. And so that's a really nice byproduct of this process. And those capital opportunities could be potentially rolled into a retro commissioning project, or it could be identified as a future opportunity for a project for that customer. So what are the savings that we can expect from these projects? So I referred to this landmark study by Evan Mills and his team that took place in 2009, 2010. About a decade later, around 2020, he and others published a follow-up study to this that spanned 3 decades and involved about 1,500 buildings across North America that had undergone commissioning in some form or fashion. What I've displayed here are some numbers that he found in that study, that in the median savings for projects within utility programs was about 5% of savings. If monitoring-based commissioning was incorporated there, and I'll talk a little bit more about that in a little bit here, that number jumped up to about 9% of median savings. And then for projects outside of utility programs, it was a little higher at 14%. I don't know all the reasons for the differences there, but a couple of things that come to mind for me is that often within utility programs, we address maybe just one side of, or one side of the energy consumption is claimed, right? So an electric utility might be focused primarily on electric savings, a gas utility primarily on the gas side. Also within utility programs, there could be more of a focus on some of the more prescriptive type measures to be implemented within this. So some of the reasons why there might be a bit of a difference there. But again, this is median, so there are a number of projects that perform much better than these numbers and others that were a little bit lower. In terms of cost, from the same study, they found the median cost was about 26 cents per square foot in US dollars. This resulted in a median simple payback time of 1.7 years. But even looking at that 25th to 75th percentile range, we were still under 4 years across the vast majority of these projects that were looked at, again, in over 1,500 buildings. So a really attractive measure with good payback time. I'm going to talk a little bit about persistence of savings because it's important that not only do we save energy in these buildings, but hopefully what has been implemented will persist over time. So there's been a few studies that have looked at how long do savings persist through these retro-commissioning measures. One study a few years ago that was published in the ASHRAE Journal found persistence in the range of 60 to 75% a few years after retro-commissioning was performed. Another study that I personally was involved with looking at some university buildings across a long period of time found on average that energy savings declined by 8% down to 4%, depending on heating, cooling, or non-cooling electricity use, in the absence of further intervention. As a general rule, if you come across a building where it's been about 5 years or so that retro-commissioning has happened, in the absence of other follow-up, it's worth taking a closer look to see if that would be a good candidate for RCX. There are definitely factors that influence whether savings persist. So one of those I alluded to earlier is training of facility staff. If facility staff understand what has been implemented and why, they are less likely to later override those measures that have been implemented. The internal BAS management and staff turnover are big factors there. So if the person who is operating this facility, who's operating the control side, retires, someone new comes in, that can be a factor in whether those measures are going to persist, if that person has a good understanding or not. And then if there's major retrofits, sometimes measures that were implemented get overridden when new equipment or systems are put in. So just a few recommendations to help things persist better. One I've already talked about a little bit, and that's having training of operators. But not only training those that are currently there, but recording this training, having some program manuals that are part of this process that will allow, if there is turnover, that new people coming in can understand what was implemented and why. Utility programs can have a big influence in persistence as those discussions happen, and even in some cases as incentives are given to promote the persistence of savings over time. Finally, follow-up activities to briefly revisit spot check, including monitoring-based commissioning, which does add cost to this process, but would allow for continuous follow-up of the measures and identifying areas where savings may be degrading. Let me give you just a couple of of case studies to give you a flavor of kind of how this process works. One of these is from a project that was done recently in Oklahoma. This RCX process was done by a trade ally within a utility program. And this trade ally went to this hospital. This is a hospital with 190 beds. It's full service. Its baseline annual electricity consumption was over 16 million kilowatt hours, so a large user of electricity. So our trade ally went in, performed an assessment and a deep dive, a detailed review of facility equipment and systems, including the building automation system and its programming, and looked at and recommended and then implemented optimized control sequences and programming, including developing room ventilation schedules, room set points, and really trying to go through and optimize on a space by space and equipment and zone by zone level how this facility was operating. They created new energy efficient programming for air handling units, chilled water systems, and heating water systems. The result was pretty significant savings. As you can see here, this is from the measurement verification period over a 12-month period post implementation of these measures as compared with the baseline. And what we found, what they found and we verified was that they saved over 1.6 million kilowatt hours. Again, using 16 million kilowatt hours annually, so this was about 10% of this customer's electricity consumption that was reduced. Now, there was gas savings involved in this project. However, this was done through an electric utility program, and so I don't have those numbers of how much gas was saved there as well, but that was a product of this process for the customer, although there were not incentives involved for the gas savings. But this project involved incentives of over $177,000 back to that customer for this project. Another case study, this was one that CLEAResult's design build team did direct to customer for a large data center. So we went in and implemented a number of measures, including optimization on fans, on air handlers, on pumps, on the water side with chiller optimization, as well as cooling towers. And what you see in these series of graphs, I know they're small and hard to read, but in the middle there, the option B is where through measurement and verification, we looked at on a system by system how much was saved, just looking at it individually. Adding those together came up with about 2.2 gigawatt hours per year of savings. However, as we looked at that across the whole facility meter, which better considers interactive effects and effects even outside of those specific systems, we found that it actually had saved 3 gigawatt hours per year, which was about 10% of that whole facility energy consumption. So I want to talk some about program design and what some things you might want to consider as you were thinking about how to drive and implement retro commissioning within your utility programs. So I alluded to in a previous slide some of the different program types that we at CLEAResult are involved with our partners, with our utility partners out there. And so just to kind of generalize how we typically engage with those. So we've seen retro commissioning. This is probably the most common way. Retro commissioning as a measure within C&I, commercial industrial programs. But we also see retro commissioning as a standalone program. And there's a number of ways that is done. I've listed some here. In some cases, a qualified service provider or trade ally will perform that initial study and assist with implementation. In some cases, CLEAResult engineers are doing the initial study while the customer and perhaps other trade allies are implementing the measures. In some cases, CLEAResult or that qualified service provider would do the study and then engage with the customer to help with implementation of those measures. And in some cases, we see utilities incentivizing or building in savings or persistence of savings as a phase to this. We also have this offering called RCX Lite that is really tailored towards the smaller buildings, under 100,000 square feet, where it may not make sense to go in and have a full engineering firm study with measurement and verification. So we have come up with a calculator that many of your evaluators or those programs that we've worked with your evaluators on have approved for being able to generate savings quickly, not having to do extensive measurement verification for these simple systems and simple measures. That's been a great offering for harder to reach customers on the commercial side. It's a faster process that involves simpler M&V. So I just wanted to outline kind of an example here of a tiered approach for retro commissioning. Doesn't mean that this would be the optimal approach for you or your market base, but it's just an example. So in this example, we have 3 tiers: small, medium, and large facilities. In our small facilities, that would be 25,000 up to 100,000 square feet, we're looking at an RCX Lite approach. We've got a trade ally that's probably not an engineering firm, most likely a mechanical or controls contractor, that's going out and doing these studies and finding some simple quick fix measures within these facilities, and then claiming those savings through the RCX Lite calculator. So it's a fairly quick process. Customer can get through it quickly, can have a quick impact to start saving energy in those smaller facilities. Then in this example, there's a medium facilities tier where it is a full retro commissioning approach. We've got a study that's driven either by CLEAResult engineers or qualified service providers. The customer implements those measures. And then there is still, there's more complex M&V than the RCX Lite tool, but it's still not necessarily a full whole facility consumption measurement verification. So we look at, just using trend data and looking at specific systems to kind of simplify that process. And finally, for the larger facilities, those big ones, 300,000 square feet and greater, in this example, they would have a full retro commissioning approach with the study, with the implementation, with the full IPMVP compliant measurement verification. And those incentives would then typically be available both on the study side as well as the implementation. There may even be a persistence phase that's built in with additional incentives for these. So again, an example, maybe not adequate for every situation, but it shows how different facility types could be dealt with within a program like this. Now, as you are thinking about retro commissioning and what it should look like in your programs, some of the things that you'll want to think about, potential challenges to consider. Number one is how to drive participation. And so, a few things that need to be there to drive these, and that's good incentive rates that will help customers and trade allies want to participate in this. Recruiting, outreach, and training of those who are providing these studies, as well as customers, so that they understand how the program works and why this could be a potential benefit to them. And then the way that incentives are paid and the timing of that. So, one of the realities of the retro commissioning process for larger facilities is that it takes a while to get through the project. It can take over a year for this project to completely be implemented. And it can take up to another year for measurement verification to be finalized. And so sometimes the way that those incentives are paid, if you can pay an incentive on that study kind of up front, and then upon implementation, pay a partial incentive of the expected savings that are going to happen, and true that up at the end with that final incentive payment. Sometimes that can help a customer to get through this process easier. Another challenge to consider is you want customers to not only get the study done, but to actually implement the projects that are going to save energy and result in savings in your programs. So some of the ways that we see utilities engage here to help that happen is to build some skin in the game for the customer. Sometimes that's done through a contract that says, hey, if we're going to incentivize your study here, we need you to commit to implement any measure that's recommended that has a payback period below X number of years, for example. Or you're going to implement a certain percentage of these recommendations, or your savings are going to amount to a total of at least X. Those are things you can build in to try to help make sure that the customer doesn't just get the report and say, oh, this is great, and then not act on it. Also, building in some follow-up or persistence is a great way to make sure that not only are those implemented, but that those savings persist over time. Finally, just consider program cycle, timing, and goals. Again, some of these projects can take quite a long time to develop and implement, and measurement verification. And so that needs to be considered as you think about a program cycle. Finally, retro-commissioning is most effective at energy savings, although it can produce and does produce peak demand savings. But many of the measures that we're looking at have to do with optimizing consumption, reducing energy waste in periods of time when the building is lightly loaded or during shoulder seasons. And so sometimes that can result in more energy savings than peak demand savings that happen. But both are opportunities, electric and gas side. So just want to take a couple minutes here to talk about some future trends and things that we're starting to see here that go even beyond retro-commissioning. So one is one that I've alluded to already, and that's monitoring-based commissioning. And this is not future, this is happening now, but it's kind of an add-on to retro-commissioning, because not only is it a one-time come in and implement these processes and projects, but it is a continuous monitoring after the fact to look at, well, what are some additional savings that could be found? Where are we seeing things start to degrade? Where are we seeing set points starting to be changed? How do we help that customer to go and address those issues quickly to continue to get savings? Just a quick case study here. Our design build team at CLEAResult works with customers on in a monitoring-based commissioning scenario. So in some cases, they will go in, for example, with this case study, there were 2 office buildings that were cooled by air handling units and central utility plants, where our team, our design build team, was looking on a monthly basis, looking at data that came back from these customers and just seeing how things were operating and identifying measures that could be implemented or fine-tuning or tweaks that needed to happen across these buildings. What they found were some great results. So on this month-by-month basis of using analytics to find where there were opportunities, they found that just in a period of 9 months, they had already saved 300,000 kilowatt hours and over $51,000 in cost savings for this particular customer. So again, monitoring based, there's an additional cost to that. Obviously, you're paying for additional monitoring. However, it can have a great impact on savings and persistence. One of the newest trends that we're just starting to see out in the industry is the use of AI, artificial intelligence, in commissioning. AI is a big buzzword in many industries at this moment in time, but specifically within commissioning, we are seeing companies who are coming in and coming up with building this digital twin using building information of the building. And so in the cloud, they've got this model basically, but it's a real-time model of the facility, and it's being fed real-time data from the building automation system, from weather forecasts, from utility data, many other sources, and then using artificial intelligence, using these AI self-learning algorithms to then send direct control commands to the building to try to optimize how it's operating. So really kind of a fascinating cutting edge type opportunity We're starting to see a few of these projects come in, so we're looking forward to learning more about how this works and seeing, kind of how it plays out in real life. So in summary today, I know we've talked about a number of things, but I just want to leave you with the why retro commissioning is important. Leave that thought in your minds today. It's a big opportunity. There are a lot of buildings out there that use a lot of energy. And as we have gone into great depth to try to talk about today, a lot of wasted energy within those buildings. Retro commissioning is so attractive because, for one reason, its payback period is short compared to some other capital investment type opportunities that a facility owner might be looking at. And if we pair that with utility incentives, that payback period gets even shorter and more attractive for that customer. So how would you engage here? Well, determine what your level of opportunity is. What does your market look like in terms of commercial buildings that are out there? If there are large commercial buildings, there is most likely a good opportunity for retro commissioning. What trade partners are there who can perform the work? Again, as I alluded to earlier, sometimes that can be a difficult thing in a local market, but there are plenty of firms throughout the United States and Canada who can do this work and do it well. And then determining what your program or offering should look like. How are you going to reach that specific market segment for your market? What do those incentive rates need to look like to drive trade allies and customers to want to perform the studies? What should those rates look like for the final savings to make this an attractive measure, but also to be cost effective from the utility standpoint? And then looking at how do I build out a trade partner network? What kind of outreach strategies do I need to look at in order to make this most effective? And then how to structure it so that I can reach all the customers that I want to reach. So that's the summary I'll leave you with. I hope that you have come away with a sense of the opportunity here, how exciting it is, and the savings that can be had for your customers as they engage in this process. With that, I will open it up to any questions, and I guess, Nick, I can maybe turn it back over to you for that side of it if you want to moderate that.
Yeah. Hey, Corey, can you go back to slide 30? So our first question today, it refers to slide 30, where we talk about some of those median costs.
All right, sorry about that. Got a little aggressive with the clicking here. Let me get to 30 here. Got a little bit of lag on the screen, so. Okay.
There we go. So this median cost, is the median cost for the study or the study and implementation?
Yeah, that's a great question. And so it varies a little bit. Again, this is a huge sample of projects. It is supposed to include at least some level of implementation there. I will tell you from personal experience that, if you've got a larger building with some complexity to it, talking about the study and implementation, you're going to be higher than that cost. Usually, customer will be. However, that payback period will still be good because with that higher complexity and deeper dive, you will also hopefully be achieving greater savings there. So yes, this is a median cost, but I would, take that with a bit of a grain of salt because it does vary a lot depending on the building and the program and the implementer as well.
All right, I believe this next question refers to a slide before this one, slide 29. So monitoring based utilizes option C, evaluation, which typically requires a minimum of 10% overall savings to qualify. otherwise too much noise, difficult to evaluate? I think that may be more of a comment than a question, but
Yeah, I appreciate that, and I believe our last engineering series was about measurement and verification specifically. So, but just to speak to that a little bit, so 10% is a rule of thumb for savings in an option C analysis. However, it really depends on the statistics of that project, and depending on those statistical parameters, you can capture much lower than 10% and still do an option C. I can't speak to this particular study necessarily on how the savings were quantified across these. I don't think it necessarily has to be an option C to understand the savings. Monitoring base could also be looking at individual systems and utilizing trend data and more of an option B type approach as well. But I do appreciate that comment. Yeah, it's a good point that you want to make sure in any measurement verification that you are outside of the noise as you are quantifying these savings, and that will be important as your trade allies implement projects.
so did they mention what RCX measures they're implementing outside of utility programs? What are we missing? So I believe that refers to the third bullet here. I think, Corey, you said that was could be some of if it's a gas savings versus and it's a utility program.
Yeah. I mean, I think that that's part of the issue. I also think, this is looking at a study over 3 decades, and so there is a lot of material, a lot of projects, and some utility programs that were just designed to be pretty simple. Let's go in and just target, the low-hanging fruit, and not necessarily an engineering firm coming in and doing the full retro commissioning, which I think we tend to, in this study, tend to see more of outside of the utility programs. However, what I'm seeing, what we're seeing today is that I think utility programs tend to be a lot more robust now than they were in the past in terms of really incentivizing a deeper dive. Now, I will caveat that with, I did talk quite a bit about retro commissioning light and some of those opportunities to do a quicker look, maybe not quite as deep a dive, and within buildings that are less complex. So it stands to reason that those are going to achieve savings quicker, but with a expected to be a little bit lower savings potential in those types of projects. So I don't think we're necessarily missing measures. I think it just comes down to what makes the most sense for you to focus on. And again, to me, thinking about different tiers where we address, here's some quick hit, smaller buildings, simple buildings, we can really have an impact. Here are our big hospitals and data centers, we can really do the deep dive and have the engineering study and expect more savings, but more time commitment to get through that. So appreciate that question though.
Have you seen changes in occupancy impact the ability to implement RCX? How has it impacted savings analysis / M&V?
Yeah, that's a great question. And, I will admit here that, as I showed this data from CBEX and that being a 2018 being the last iteration of that study, I mean, obviously we've had some huge impacts globally with real estate, commercial real estate in particular, with COVID and its impact. So I don't have a precise answer on that. I mean, I think what we're seeing across the industry is that occupancy rates are going back up, obviously over where they were during COVID, during the pandemic, when it was at its height. But the reality is, in some of those buildings, it's not ever going to be where it was, and some of those may be transitioning to different types of usages. So I think in some cases it's maybe limited the opportunity, but on the other hand, there are cases where that opportunity maybe has even increased because a building that was, being utilized as a data center or in some way before is now that's changed the way it's been being used. And so there's an opportunity to go in and look at, well, have we adjusted our heating, air conditioning, and control systems to really match how it's being occupied and utilized now? So, it's kind of a mixed bag. We've got, in some cases, maybe that opportunity has reduced, but in other cases, it's an even better opportunity to go in and try to optimize to current usage of the building. And that's the beauty of retro commissioning. It's not just, let's get this back to design. It's let's optimize it to how the building is currently being used.
All right, next question. Does CLEAResult sell the RCX Lite calculator to utilities?
We don't sell it that I'm aware of as a tool, but what we do is with our utility partners where, we're working with you, we utilize this tool, we get it approved by the evaluator, and then our trade allies are able to utilize the calculator along with our quality control checks there to make sure that it's being the projects are being implemented appropriately. So I don't think we're selling it as a software so much as just an opportunity to help within programs to implement that measure.
Right. How do you integrate building science into the RCX approach, like mold and mildew concerns, etc.?
Yeah, that's a great question. And, that is another beauty of retro commissioning and another, I guess, reason to have a trade ally network of firms that understand the building science. I mean, you certainly don't want to go in and try to save energy by doing something haphazardly that's going to result in negative effects to comfort or indoor air quality in a building. But the beauty of it is if you understand that system correctly and do this deep dive study, sometimes we can address not only the energy consumption side of it, but those indoor air quality parts. I know as someone who has done a lot of retro commissioning directly with customers, indoor air quality is a big focus of what we look at. And we want to make sure, for example, that building pressurization is appropriate so that you're not pulling in hot and humid air into your building envelope, creating moisture and mold issues. So, there's still going to be a line and a scope, right, of what you're looking at. But I would say that these projects can have a great potential impact to help mitigate some of those types of concerns.
All right, we are at time. And so if you need to jump, thank you so much for attending today. We appreciate you joining us. But we do have a few more questions here. So if you can stay on the line, we'd like to get through some of these questions that are left. And so if you can stay, that's great. If not, we'll be sending out the recording here shortly. But so Corey, another question here is, how often do customers request and pay for a study, but don't follow through with the implementation side?
Yeah, that's a great question. And, that's one of the potential challenges that we want to try to mitigate, because you don't want to pay for a study and then not get any savings out of it. So I would say I don't have a direct answer, like a number there specifically, because it really depends on how the program is written. And going back to that slide earlier about the customer having skin in the game. So, I think where we've seen the most success are utilities that have programs where that study incentive is really tied to, hey, I'm committing to implement this number of measures, or measures with the payback of this, I think that's really where you'll have the most success. We have seen certain cases where, you know, that wasn't necessarily clearly outlined, and we've seen, you know, studies get paid for and no projects get implemented, or you know, a lot of projects not getting implemented. And so that's kind of a lessons learned just from experience we've seen, that you really want to have that skin in the game.
Are there any types of large buildings that have proven not to be a good candidate for RCX?
Yes. So I guess I could go back to, see if I can get back to that slide real quick about kind of some focus areas.
Which side?
This is slide 10 here, where I was just talking about what makes a good candidate. So HVAC system and building automation system are a big part of whether or not a building would be a good candidate. So, you know, we have definitely seen, I've seen in my experience where maybe there is a large building, but they don't have a good building automation system, or they're primarily local control or pneumatic control. Seen this more in older buildings typically, but it could still be a good opportunity. But the reality is you have to consider what could be implemented out of this project. And so if you're going in to try to do a study, a retrocommissioning study, to find opportunities to change control strategies, for example, and there aren't really control strategies because it's local control and they don't have that functionality, that's probably not going to be a good candidate for RCX. That may be a good candidate for a capital project by that customer to, you know, add the right levels of controls. So I don't know if it's so much a building type as a capability, but you know, sometimes we learn in those retro commissioning assessments that there's other factors that maybe make it not as good of a candidate. It's very rare, but sometimes you come across a building where they've done a whole lot of optimization, and maybe this isn't a good time to do it because there just aren't necessarily the savings to be found there. But that's pretty rare. I mean, most of the time there are savings opportunities that can be had, but I've definitely seen somewhere the customer's already shutting things off at 3 p.m. and, you know, running everything at 79 degrees for cooling and 63 degrees for heating. You know, they're already kind of bare bones on how they're operating. May not be a huge opportunity for retro commissioning there. So I hope that provided a little bit of help. I'm happy to, you know, we are happy to connect with any of you and address more specific questions later as well.
All right, this will be our last question, and I don't know that we'll be able to answer this without knowing the specifics, but maybe Corey, you have some experience. Omar says, I have a university that wants to do RCX, but they're part of our CEI program. Can they get incentive dollars for both?
So that sounds like a specific question to a utility program that's not going to be applicable to everyone here on the call. So maybe we can connect about that.
Yeah, so Omar, let's connect afterwards.
Yeah, I mean, I can just speak very generally to, you know, one of the ways that we at CLEAResult engage with you all, our utility partners, many of you, is with strategic energy management type programs that focus on low, no cost measure implementation by a customer. And so in areas where that's happening, there is obviously some overlap between that and retro commissioning. And so it's sort of a case by case to look at Does the customer have the ability to just go in and make these changes themselves through that SCM program? Or does this need to be a capital project where, you know, they hire a firm to come in, do the study, help them implement, and then that kind of gets rolled in as a capital project? So that's getting into the weeds a little bit between those specific types of programs, but I've actually have quite a bit of experience looking at those with our customers, so happy to talk through that further with anyone that would like some more information there.
All right, well, that wraps up our presentation for today. Thank you so much for everyone for joining for us, and we're happy to have you here. Hope you all have a great rest of your day. Thank you so much, Corey, for sharing your expertise with us.
It's been great. Thank you all.
Goodbye, everyone.